Hey, very good morning, students. Let us look into the flip-flop conversions topic. We know there are four types of flip-flops. One is SR flip-flop, D flip-flop, JK flip-flop, and T flip-flop. Now, we will see how to convert a flip-flop into other type of flip-flop. It means SR to JK or D or T or D to JK, SR and T. It's a very important topic and a very easy topic. Let us see the steps for converting. The steps for converting flip-flops from one to other is same irrespective to the type of flip-flop. So let us see the steps. There are 5 steps which is used for converting a flip-flop. First step is you need to understand the question. Here the question is convert SR flip-flop to D flip-flop. So what is available flip-flop? SR flip-flop. I need to convert to D flip-flop. So available flip-flop is SR. The required flip-flop is D. So first step is note the available flip-flop and required flip-flop. So what is that I'm going to do? What is the question? Convert SR flip-flop to D. So available flip-flop is SR, required flip-flop is D. That is my step 1. What is step 2? Write the characteristic table of the required flip-flop. So I need to write the characteristic table of the required flip-flop, which is D in my case. So here we need to understand, we should always remember all the characteristic tables and excitation tables of all the flip-flops. That is very important to do what? Flip-flop conversions, whether it is JK or D or T or SR. You should really remember and memorize characteristic table and excitation table. Now, what is the second step? Write the characteristic table of required flip-flop. So, what is required flip-flop? D. So, I have written the characteristic table of D flip-flop. It is very easy to write the characteristic table of D flip-flop. You know, characteristic table is nothing but you need to write the next state based on the present state and the input. So, since it is D flip-flop, input is D. What is D? D stands for data flip-flop or direct flip-flop. Whatever input you give in D terminal, that will come as the output. Can you say D? Since the next state depends upon the present state and D, 0, 0, 0, 1, 1, 0 and 1, 1. Output and the input should be same. D is the input. Whatever input you have in the D will come as such to the output. This is the characteristic table of D flip-flop. Now what is the third step? Third step is write the excitation table of available flip-flop. So I need to write the characteristic table of D flip-flop, required flip-flop. In third step, I need to write the excitation table of available flip-flop. So what is available flip-flop? SR. So I need to write the excitation table of available flip-flop here. After writing the excitation table of available flip-flop, now come to the next step. Now what is that you need to do is, you need to first write the characteristic table. See the characteristic table of the required flip-flop, QN, D, Q of N plus 1. From this characteristic table, with help of excitation table, you need to fill what is S and what is R. What is S and R? S and R are available inputs. Let us see how to fill it. You need to take help of excitation table. See this excitation table. So what is the input to excitation table? Qn, Qn plus 1. What is Qn here? 0. What is Qn plus 1? 0. When Qn is 0, Qn plus 1 is 0. What is the values of S and R? 0 and don't care. 0 and don't care. Have you filled it? Have you mapped D to SR? Now do the next thing. If Qn is 0, Qn plus 1 is 1. What is the value of SR? Qn is 0, Qn plus 1 is 1. What is the value of SR? 1, 0. So write 1, 0. Qn is 1, Qn plus 1 is 0. Qn is 1, Qn plus 1 is 0. What is SR value? 0, 1. Right? 0, 1. Both Qn is 1 and Qn plus 1 is 1. What is the value of SR? Don't care and 0. Don't care and 0. So you have filled it with the characteristic table. Can you see this is characteristic table of required flip-flop. From the characteristic table of required flip-flop, we are writing what? The SR values based on the excitation table. Clear? So that is your step 3. What is step 4? Solve the Boolean expression. So I need to get the expression for yes, I need to get expression for R. So this is the expression for S and R. What are the two inputs you have? D, Qn and D are the two inputs. So how will you mark it? Zero. What is the Q of S value? 0, 1, 0, don't care. 0, 1, 0, don't care. Is it clear? Two inputs, Q and D. So fill the two inputs, Q and D. What are the outputs of yes? 0, 1, 0, don't care. 0, 1, 0, don't care. Now do the grouping. This two can be grouped, right? If this two is grouped, what is common here? Common is D. So S is equal to D. Done. Now come to R. Q and D. Q and D. What are the R outputs? Don't care 0, 1, 0. Don't care 0, 1, 0. Done. Now mark these two can be grouped. Okay, because it forms a pair. What is common for this? 0. 0 means D bar. So S is D, R is D bar. Here I have done identifying what is value of S and what is value of R with respect to D. I am done with this. What is that next thing I need to do? I need to draw the circuit. After solving the Boolean expression, I need to draw the circuit. What is available with me? Available flip-flop is SR. So I need to draw SR flip-flop. SR flip-flop has S input, R input and clock input. Q as output, Q bar as the output. Now this SR I need to convert it to what? Flip-flop I need to convert it to D. How will I do? S is equal to D. So yes, I'm connecting directly to D. R is equal to D bar. So I take from the D, I take a inverter. So I get D bar that is connected to R. So in this way, I convert my SR flip-flop to what flip-flop? D flip-flop. Is it clear? This is how we do the conversions. Any flip-flop students, whether it is JK to SR or D to SR or SR to D, what is the first thing you need to do? First, you need to understand what is available, what is required. Here I need to convert SR to D. So SR is available, D is required. Okay. What is step 2? Write the characteristic table of required flip-flop. So you know required flip-flop is D. So write the characteristic table. Third one is write the excitation table of available flip-flop. What is available flip-flop? SR. So write the excitation table. From the characteristic table, you need to obtain the values of S and R based on Qn, Qn plus 1. Based on Qn and Qn plus 1. Right? So after this, use S, obtain the Boolean expression for S and R and draw the circuit. Okay? Thank you.